Let's look at the Monty Hall problem. Suppose you're on a game show with 3 closed doors. Behind one door is a car, and behind the other 2 doors are goats. You choose one door, but it's not opened right away. Monty, the host, who knows what is behind each door, then opens one of the 2 remaining doors and reveals a goat. Monty never opens the door you chose and never reveals the car. After this, you're given a choice. You can either stay with your original door or switch to the one remaining unopened door. Is it to your advantage to switch? For most people, this feels like a 50-50 situation. There are 2 doors left, 1 car and 1 goat. Since the host already removed one losing option, it seems like neither door should have an advantage. Most people will say that switching doesn't matter. Staying or switching feels equally likely to win. And that reaction makes sense, because at first glance nothing seems to separate the 2 doors. The mistake in this intuition comes from treating the host's action as if it were random. It feels like the host just happened to open a door and reveal a goat. But that's not what's actually happening. The host's choice is constrained. He knows where the car is, and he deliberately avoids revealing it. That means the door he opens is not arbitrary, it's carefully chosen. Once you account for that, the symmetry between the 2 remaining doors disappears. It's no longer 50-50. Let's go back to the moment when you first chose your door. At that point, there were 3 options. The probability that you picked the car was 1 out of 3, and the probability that you picked a goat was 2 out of 3. If your original choice was correct, which happens 1/3 of the time, then switching will cause you to lose. But if your original choice was wrong, which happens 2/3 of the time, the host is forced to reveal the only other goat. In that situation, switching will always give you the car. So switching wins in every case where your initial pick was wrong. This leads to the key conclusion of the Monty Hall problem. If you stay with your original door, you win the car 1/3 of the time. But if you switch to the other door, you win the car 2/3 of the time. Switching doesn't just help, it actually doubles your chance of winning. Even after seeing this math, many people are still uncomfortable with the result. To make this even more clear, imagine the same game with 100 doors, and you pick 1 door. The host then opens 98 other doors, all revealing goats, leaving just 2 doors closed. At that point, staying with your original choice feels much less appealing. Switching suddenly feels obvious. The 3-door version follows this exact same logic, it's just harder to see. So the answer to the Monty Hall problem is clear. If you're offered a chance to switch, you should always take it. Let me know your thoughts and what you would do in the comments below. Thanks, and we'll see you next time.